Alright, so today we're going to talk about systems of inequalities. And so the definition here of a system of inequalities is two or more linear inequalities that are graphed together. So the solution is the overlapping region of points that satisfies both inequalities. So just as we discussed already about linear inequalities, how we graph them and we shade to find our range of solutions, the system of inequalities, we would shade each of those inequalities, and then the overlapping region that's location that's double shaded will be our solution area. Okay, so here's an example. Sherry's trying to decide how many baseball and soccer games she wants to attend this spring. Travel time to baseball games is 2 hours and soccer games is 1 hour. She doesn't want to spend more than 15 hours traveling to the games. In total, she would like to attend at least 8 games. So we are looking for, in this question, how many games, how many of each type of games we can attend. So I'm going to define B as being the number of baseball games, and I'm going to define S as being the number of soccer games. So there's a little bit of information that we have here. So we know that total she wants to spend less than or equal to 15 hours traveling. It's 2 hours per baseball game and 1 hour per soccer game. We also want to know that she wants to spend greater than or equal to 8 games. She wants to go to at least 8 games, so 8 or more. Okay, and that would include baseball and soccer games in total. So that's where our two equations, or our inequalities, are going to come from. So we end up with the first one, where we have less than or 15 hours for our condition. 2 of those hours per baseball game plus 1 per soccer game needs to be less than or equal to 15 hours. Okay, the second inequality, or the second condition that needs to be met, is that together the number of baseball games and the number of soccer games needs to be greater than or equal to 8. Okay, so when we go to graph these, just like we talked about with linear inequalities, we need to rearrange them and get them into slope-intercept form. So I'm going to treat B as my x value, so these are going to be number of baseball games. And I'm going to treat y as my s, and so that is going to be number of soccer games. So I need to solve for s on these. So I'm going to subtract 2b, and I get s is less than or equal to negative 2b plus 15. And that's going to be the first inequality that I graph. So I start with a slope, I start with a y-intercept of 15. So hopefully I have enough spots here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yep, at the very top here. And a slope of negative 2. So I'm going to be going down 2 and over 1 each time. And continuing that pattern. Okay, so that's going to be kind of the outline of my line. Now here I need to subtract b. So I end up with s is greater than negative b plus 8. So I have a slope-intercept of 8. And a slope of negative 1 this time. So I'm going to go ahead and plot my points. Okay, and so you'll notice that I did not connect my lines yet, because when we talk about linear inequalities, we have to decide if that line is dotted or solid. So we have an equal to symbol on both of these, so both of these are going to be solid lines. Now, just for the purpose of being able to see this a little bit better, I'm going to use a couple of different colors of pen so that you can kind of see a little bit better what I'm doing here. So I'm going to shade the first part of this in purple. So this first one, this first line up here is less than or equal to. So I'm going to be shading below. So I'm going to shade all of this portion below this in purple. Okay, then you'll notice here we have a greater than symbol. So this bottom line here, we're going to be shading above that. So I'm going to shade that in orange. So everything greater than that. Okay, so what you'll notice is that there is a doubly shaded area here that kind of falls in between these two lines. And I'm just going to make it a little easier to see, and I'm going to darken this area in black. So you're going to use pencil or something light enough to be seen. Just to show up on the camera, I'm having to use some darker colors, but it's going to be anything in this area right here that's going to be my solution. So she can go to any of these combination of games in order to satisfy both of her conditions. So looking at those questions, here's what they say. Suppose that Sherry decides to attend 4 baseball games. So we count over to 4 baseball games. What's the range of soccer games that she can attend? Well, if I look up that line, the lowest number where it crosses is going to be, let's see, 4 games. And that continues up to right about here, which is 7 games. So from 4 to 7, and because these lines are solid, she could go to 4, she could go to 7, she can go to anywhere in between. So those 4 and 7 are also included. So we can use interval notation to represent that. Now, suppose she decides to attend 9 soccer games. What is the range of baseball games that she can attend? So this time we're going to go up the y-axis here. And we're going to start here. So she could go to 0. That's a possibility. And then we look over, and this is all in black. So 1, 2, 3 appears to be the furthest point there. And then after that, it's not doubly shaded anymore. So from 0 to 3. 0 is part of the solution, 3 is part of the solution, so we can use brackets there to represent that. So it's anywhere from 0 to 3, anything in between. So 0, 1, 2, or 3 games. And then finally, can she attend 6 baseball games and 4 soccer games and still meet her condition? So I count this out to 6, 1, 2, 3, 4, 5, 6, and I count up to 4. And I put a point right there, and you'll notice that that point only lands in the orange section, not in the doubly shaded. So no, that would not satisfy both of her conditions. It would be greater than 8, but it would also put her too far into her hours that she wants to travel. Okay, so that's kind of the guided example to get us through systems of inequalities, just a basic idea and understanding of how they work. We'll back up and do some practice with just shading and graphing these linear inequalities in the next set.